Dinosaurs hold a particularly important place among prehistoric animals of the Mesozoic era.
Many dinosaur species dominated Earth. Let's talk about their lesser-known but fascinating ancestors.
And their struggle for a place in the sun. This is how it all began. The supercontinent Pangaea changed the climate, flora, and fauna. The Permian period, or simply the Permian, began 300 million years ago.
It marked the end of the Paleozoic era and lasted 47 million years until the Mesozoic era. During that period, the two continents Laurasia and Gondwana merged to form the supercontinent Pangaea. The colossal panthalus ocean surrounded its coast. This merging significantly changed the climate. In the preceding Carboniferous period, Earth was warm and humid, with many lakes, rivers, and swamps. Forests of giant spore plants, like ferns, mosses, and club mosses, covered the land. Trees had trunks 1.5 meters in diameter and grew up to 10 meters tall.
Giant fungi of the Protodaxite species grew taller than two-story buildings through the mists of the swamps.
In the oceans, carnivorous fish existed, looking like bizarre creatures. One of the distant ancestors of sharks, Helicoprion, was perhaps the most terrifying, with its spiral jaw. Its spiral-shaped teeth were 2 to 3 whorls long. Its body was 10 to 12 meters long, and the tooth whorl reached 90 centimeters. Despite having sharp teeth, Helicoprion could not break hard shells, only eating soft food. On land, animals were not numerous, but some species were large. Even insects of that time were huge. Imagine giant dragonflies like Meganurids gracilis flying over lakes, with wingspans over 30 centimeters. The ancestors of today's cute dragonflies were ugly and terrifying, with predatory jaws and bulging eyes. A distant relative of modern centipedes, A. arthropleurae, lived in swamps, reaching up to 3 meters in length.
These giant insects ate tons of plants each year, and also enjoyed eating small amphibians.
These giant creatures appeared due to excess oxygen in the atmosphere, with oxygen levels reaching 35%.
About 14% higher than today. There is a theory that insect size depends on high oxygen levels.
The insect's respiratory system consists of tracheae, tubes that deliver oxygen to the organs.
Insects cannot grow larger at current oxygen levels. With larger size, tracheaes would be longer. At current oxygen levels, oxygen cannot reach the organs. Higher oxygen would supply enough oxygen. This would allow insects to reach large sizes, like in the Carboniferous period. If oxygen increases to 40%, insects would once again become giant monsters. Scientists calculated dragonflies could reach the size of a small airplane,
And beetles would be as large as a small tank. Oxygen levels affect animal size. At lower oxygen levels, science has not revealed an exact explanation why. One theory suggests higher oxygen levels allowed large animals to receive more oxygen to their muscles. High oxygen levels were good for rapid development
and growth of embryos and eggs. With the onset of the Permian period, atmospheric oxygen decreased.
That is why large insects and other species lost their size advantage and became smaller.
This evolutionary change did not happen overnight, but lasted for millions of years. The formation of Pangaea significantly changed the climate. The Carboniferous climate was almost uniform.
Now, the climate became colder and more diverse. The southern part of Pangaea was covered by ice.
The southern part of Pangaea, including modern India, Australia, and South America, was covered by ice. Hot, arid deserts were in the interior of Pangaea. Earth had more deserts than ever before. Coastal areas had moderate temperatures and humidity due to the ocean. The Permian climate was like ours.
Climate changes destroyed old flora and fauna. Ferns and club mosses could not grow and spread.
As swamps shrank, spore plant diversity decreased, and gymnosperms began to dominate the planet. These included ginkgo trees, conifers, and palm-like trees. Animals adapted to the new climate and arid conditions. They had to reproduce to survive on the new supercontinent. Amphibians were at a disadvantage. Their moist skin could not withstand dry air.
They survived only in lakes and swamps. It is not surprising that many amphibian species became extinct.
In contrast, reptiles quickly spread across the globe because they adapted much better to the new environment. In the Permian period, reptiles accounted for 53% of all tetrapods, compared to 13% in the previous period.
Initially, reptiles were small, similar to modern lizards. They mainly ate arthropods and worms. Over time, larger species appeared to hunt smaller ones. Most were carnivores with powerful jaws and sharp teeth. Nothing could stop reptiles from completely taking over the planet. However, a real catastrophe occurred on Earth.
What happened? In the last days of the Permian period, Wayne
Lived in the food-rich oceans. Dimetrodon was one of the most successful predators of the Permian period.
Its sharp teeth were unlike most reptiles, including incisors and serrated teeth, well suited for eating meat.
Its dorsal sail was a huge advantage. Dimetrodon used it in mating displays, camouflage, and swimming.
The sail helped regulate body temperature. It also helped hunt early in the morning, before other creatures woke up and moved. The sail was also useful when rivals like trematopods appeared on the way. Trematopods were carnivorous amphibians, up to 80 centimeters long. They were well adapted to life on land, as they needed time to warm up their cold bodies. That is why they easily became prey for the larger and more agile Dimetrodon. In the Permian period, all species sought food. Gorgonopsia, 3 meters long, was an ancestor of mammals.
It did not need to warm up in the morning, being warm-blooded and partly covered in fur.
Gorgonopsia also had saber-like teeth and a third eye on top of its head, like a periscope. This reptile was used to hunt at dawn, the best time for hunting. Gorgonopsia also had a well-developed brain and cerebellum, helping them with good movement coordination. Gorgonopsia did not hesitate to hunt larger prey. Let's combine all the details, and you will get a picture of the most dangerous predator of the Permian period.
Gorgonopsia even hunted 4-meter-long Periosaurus. With 15-centimeter-long fangs, Gorgonopsia could bite through the hard skull
Of this clumsy animal. Its hunting strategy was a series of attacks and retreats. First, it jumped on the prey.
Then bit and retreated. It attacked again until the prey died from pain. Cynodonts were distant ancestors of mammals, resembling weasels. They were up to 60 centimeters long, warm-blooded reptiles with fur. This meant they were not dependent on temperature changes. Cynodonts could hunt at night when larger predators were resting. When hunting together, they could attack large animals and rarely lacked food. Their success depended on sharp teeth, easily tearing prey into pieces. Incisors were for biting meat. Flat molars with many sharp edges helped chew prey.
Lecodont species live deep within Pangaea, having to move and find better places. This reptile was like modern crocodiles with long legs.
Along with dinosaurs and birds, it was the first ancestor of crocodiles. Some thecodont species could move very quickly on 2 limbs. Imagine that Thecodont could travel for miles until they found a green oasis. There, they met the herbivorous Ethosaurus.
It's a slow and clumsy reptile. It was also an ancestor of dinosaurs. They had a spiky back and shell to protect themselves from predators like Thecodont. However, they were also amphibians, easily becoming prey for lunch.
252 million years ago, a catastrophe occurred deep inside Earth. Scientists discovered this by
finding ash layers. This supports the theory that the catastrophe was caused by powerful tectonic plate shifts inside the planet. After the continents Laurasia and Gondwana merged, the Earth's crustal plates continued to move.
As a result, the southern plate was subducted under the northern plate, creating large gaps on the surface.
In eras that are now India and Siberia, hot gases and magma erupted from deep within the planet to the surface. Hot, molten lava destroyed everything in its path. When magma reached the surface,
That is 4 to 5 times hotter than an oven. What would happen to the sea windons trapped in these lava flows?
and the flames spread so quickly that no creature could escape. Magma eruptions and earthquakes caused tsunamis.
High waves would hit and sweep away Dimetrodon and many other animals living in the oasis. Imagine that Thecodont and Ethosaurus were lucky, and the magma and flames did not reach their oasis.
Imagine only earthquakes and a few dust storms. But even in that case, the clock kept ticking, and they were doomed. Magma released large amounts of methane and carbon dioxide into the atmosphere. The temperature on the planet increased by at least 2 to 3 degrees Celsius and melted the methane frozen in the oceans, releasing it into the atmosphere. The greenhouse gas, methane, increased the temperature by another 5 degrees Celsius. All the water on the planet evaporated.
And the land became arid. The same happened in the oasis, where the ancestors of dinosaurs lived. Plants withered, and most animals died. Once again, the surviving reptiles had to find another place.
They continued to move, but only a barren desert remained. Toxic acid rain fell from heavy clouds. It was difficult to breathe due to dust, volcanic gases, and ash in the atmosphere. There was no chance of survival in such a hell. This is a brief description of the largest extinction in Earth's history, called the Permian-Triassic extinction.